Right, hello friends. Welcome to another day at the bench. How are you all doing today? What I have here is a little wireless charging circuit setup, which I bought a sample of. So you got your two coils over here. That's the power in. This is power out. This goes through a watt meter, and I step the 5 volts coming up to a voltage that these LEDs will run off. So when I put the two coils on top of one another, you see the LEDs come on. So what I've got coming in, you can see it over here on the power supply cam. We got 5 volts and we're drawing half an amp, so that's 2.5 watts. Now we want to know what is the conversion efficiency of this setup. So the watt meter is measuring the voltage out and the current out, calculating the power out. My code is calculating the efficiency based on those values that I've manually put into it. Okay, so on the screen here we've got 5 volts coming out. We've got a current of 345 milliamps going out to the LEDs. So I'm measuring over here what's coming out of this circuit. Okay, so that's 1.74 watts, 1.75. The efficiency is around 70%, so we got 30% losses. Okay, so on the screen you can see as I pick up this coil over here, like so, the LEDs go dim. So there we're down to about 10% efficiency, 20%. I'd say that's about 10mm gap over there. So to demonstrate it, let me take these two coils and you can see the gap. Okay, so that's together 75%, and you're still at about 68 with what's probably about 4 or 5mm a gap there. Once you get to about a quarter of an inch, you're down to 50%, and thereafter it tapers off sharply. So if you wanted this on the underside of a enclosure table or something, it would need to be at least 5mm thick, covering this or less, for this to still work nicely. So that's that. So it does work very well. 70% is not bad. I have not had a scope on this to look at the frequencies, but I know it's in the probably in the range of a few hundred kilohertz. It's quite fast. This is a cheap little thing which I bought for $170, which is about $10. So it's 5 volts in and then 5 volts out. So on the output you can see the boost converter over there. And then over here I've got another boost converter, stepping it up to 17 volts, so I can run the LEDs and give it some load. Now this thing in the advertising is rated at an amp, half that, because you're already starting to get to, I would say, just in the early 40 degrees Celsius range on both especially the input circuit over here. So if you double that current, you're going to cook it. So I'd stay at half an amp, but it works well. It's my first time playing with one of these. Interesting, and this was an interesting little setup, doing this experiment and getting this data. So this is an INA219 watt meter. It's I2C. Got a 4x20 LCD, which is I2C. Then over here is an Arduino Uno doing the maths for us, reading the two I2C devices. I'm not doing any data capture here, but I can if I want to. There's an SD card here which is still connected to this that works on SPI, but we're not trending data here, we're just doing a measurement, so no need for data to go into a CSV file. So that's it. How efficient are these? 70%. There's your answer, like that. Got an interesting little experiment. It was a fun one. I'm going to wrap it up here. Have a look at these. They also showed up this week. It is a USB, mini USB PP9, and there you can see the state of charge on it. It's got a little fuel level meter over there. So I measured this using one of these setups with a USB charger and a USB ammeter. It was drawing around 120 milliamps. Very nice. This costs about 50% more than an alkaline battery, so it's a bit more cost, but the convenience of being able to recharge it is massive. So I got two of them. They're very useful. I like it. Now you can see the voltmeter nicely over there. I keep forgetting that on the screen you guys can in the top left corner see that meter, and I'm going to stay out of that thing's way. This is working quite nicely. So there's that screen over there. It is, there you can see it nicely, 70%. It's quite hard to set the camera up to read this screen properly and make it so you guys can see it. Quite a lot of trouble that goes into setting up the camera angles and the lighting and the stuff for these videos. So that's it. We are done. Have an awesome day further. Take care. Thanks for being here. Hope you enjoyed this little demo of this stuff. And thanks. Take care, ladies and gentlemen. I'm repeating myself. See you next time for more stuff. Take care. Bye.